All right, we're going to be looking at 7.3, solving exponential equations. Let's start off with a relatively simple example, I think. We're going to solve 4x, or 4 to the power of x plus 3 is equal to 16. Well, why do you think I would have these two numbers? Well, they can be written in base 4, or they can be also written in base 2. And what I mean by that, allow me to write this in base 4. So if I say 4 is equal to 4 to the power of x plus 3, so that is expressed in base 4, my base is 4. 16, I could write it as 4 squared. Well, that was fairly straightforward, I think. Since the left-hand side is equal to the right-hand side and the bases are the same, we can conclude then that x plus 3 is equal to 2. Therefore, if I subtract 3 from both sides, x is equal to -1. Yeah, if you want, you can quickly do it. Check x to the, or 4 to -1 plus 3 is equal to 16. So 4 to the 2 is equal to 16, and that works out. So that definitely works. Excellent. Now, let me do it another way. Now, I'm going to be reducing it to the lowest prime base. So the lowest prime base of 4 and 16 are both 2. So really, this is 4 to the power of x plus 3 is equal to 16. Now, maybe I'm just going to zoom in on this part here. I can switch this by 2 by simply replacing 4 with 2 to the power of 2. And I'm going to keep my exponents. Now 16 expressed in base 2. Well, 2 times 2 is 8, or 4 times 2 is 8, times 2 is 16. So that was 2 to the power of 4. Well, we're almost there. On the left-hand side, I'm going to use the power of a power rule, which simply I'm going to multiply the exponents. Now 2 times 2 to the exponent 2 times x plus 3, close brackets, is equal to 4. Sorry, my mistake. Is equal to 2 to the 4. This ends up, so my bases are the same. The left-hand and right-hand side is the same. Therefore, my exponents must be the same. So now I have a linear equation. 2 times x plus 3 is equal to 4. I am going to multiply the left-hand side. So I have 2x plus 6 is equal to 4. Subtract 6 from both sides. Divide both sides by 2. And I get the same result that x is equal to -1. So this is two different ways of solving. Now let's look at another example. Here we have no choice but to reduce this to base 2. For I know that 8 is 2 to the power of 3. So I'm going to convert this to base 2. So 2 to the power of 3, which is 8, x plus 3 is equal to 2. Now 2, and I should make sure that it's 2 to the power of 1. So right now, I'm going to write this, the left-hand side, by using the power of a power rule. So 2 to the power of 3 times x plus 3 is equal to 2 to the power of 1. So since the left-hand side and the right-hand side are equal, and my bases are equal, this implies that my exponents must be equal to have equality. So I have 3 times x plus 3 is equal to 1. Multiplying through on my left-hand side. Subtracting 9 from both sides. dividing both sides by 3. It's pretty incredible. I would have never guessed that. X is equal to negative 8 over 3. So, moving on, a great way to start solving exponential equation is reducing both sides of the equation to the low prime base. Let's put lowest prime base. I guess I'm kind of redundant, just a prime base. So we're going to rewrite the following numbers as a power of 3. Now, you can count on your fingers if you find that useful, or you can just draw this on the top of your head. Well, we know that 89 is, well, 3 times 3 is 9, times 3 is 27, times 3 is 81. So 3 to the power of 4. So I counted on my fingers. That would be one way of doing it. Or you could say 81 is 9 times 9. Now this would be work to the side. Now if I'm trying to reduce this to the lowest common base, 9 is just really 3 squared times 3 squared, right? 9 times 9. And that would be 3 to the power of 4, which is exactly what I got. All right, let's look at this right here. 9 to the power of 4. If I'm trying to reduce this to base 3, I can say, if you notice in brackets, the green is 9. It's 3 squared. Now I'm going to employ the power of a power rule, so I'm just going to multiply my exponents. So it's 3 to the 8. All right, a lot of fun. Okay, let's move on. This one's going to seem challenging, but it's base 3. So I'm going to try to separate this into 2 parts. We'll call one the green part and maybe the pink part, just for sake of ease. So the blue part I'm going to treat as 9 squared, and by the way, they're being multiplied to each other. So 9 squared, I would say that that's 9 squared, base 3. Now, this devilish little thing here, I may want to change this to a rational exponent. So this is really 27 to the power of 3 over 4. So now 3 squared is going to be 3 to the power of 4. Using the power of a power rule, you multiply the exponents. Now, the pink part here, I'm going to change 27 in base 3. So this would be 3 to the power of 3 to the power of 3/4. Now, this ain't getting nice, is it? But I promise we're almost there. 3 to the power of 4 times. Now, 3 to the power of 3 to the power of 3/4, well, 3 to the power of 3 is really 3 over 1. A power of a power is that we simply multiply the exponents. So that's going to be 3 to the 9/4. So I'm just going to rewrite this up here because this is not very nice whatsoever. 3 to the power of 4 times 9/4, or 3 to the power of 4 times 3 to the power of 9/4. Now, I'm going to use the product of power rules, whereas provided that the bases are the same, which they are, we're simply going to add the exponents. So this breaks down into something 4 plus 9 over 4. And I need a common denominator of 4 if I'm going to add this. So this is 4, 16 over 4 plus 9 over 4. So this really is 3 to the power of 25 over 4.